All right, so today we're going to move on to some more advanced techniques, some different techniques that can be used for various circuits you might be analyzing. Obviously, the main techniques you're going to use for any circuit will be Ohm's law, nodal analysis, and loop analysis, which we discussed prior. But there are some other kind of advanced, kind of creative techniques that might work or might not work depending on the circuit you're talking about. They're specialized techniques. Sometimes they're helpful. Sometimes they make things less efficient. So unfortunately, there's no real good way to know when one should use one technique over another. It's one of those things where the more experienced you are, the more circuits you've seen, the quicker you're going to be able to tell when to use one technique over another. But basically, this is building up your toolbox, figuring out different ways of analyzing circuits, and so you'll have different tools at your disposal to mess with the circuits as you see fit. So the first big technique I want to talk about is called the voltage divider. And this is just kind of a quick way of calculating the voltage dropped by one resistor, a particular resistor, when that resistor is in series with others. So for instance, let's say we have a circuit that looks like this. Let's say this is R1, R2, and R3. This is the voltage of the source. And let's say, for whatever reason, we want to know what is the voltage across this second resistor, call it V2. Well, the way we've done this in the past is purely through Ohm's law. First thing we do is we find the total resistance of this circuit. Then with the total resistance, we can use Ohm's law to find the total current. Once we know the current on each one of these resistors, then we can get the voltage dropped by each resistor. That's perfectly fine, but there's a little bit faster way of doing this. And it turns out this technique called the voltage divider technique says if you want the voltage on the second resistor, if you have a series of resistors like this in series, then all you have to do is you take the resistance of that resistor, you divide it by the total resistance of this set, and multiply that by the voltage source itself. Okay, so this is pretty nice. Of course, the general statement Vx is Rx over the sum of all the resistors in series times the source voltage. So if I want the voltage across resistor 1, it's R1 over R1 plus R2 plus R3 times the voltage, and so on. And this is a much faster way of getting to the voltage drop by a particular resistor than having to go through Ohm's law and all of that. Note, of course, this only works if these resistors are in series. If they're in parallel, you can't just do this voltage divider technique and think it's going to work. It only works if these resistors are all in series with each other. Current divider, similarly, allows you to take a group of resistors that happen to be in parallel and calculate the current on a particular resistor. So for instance, if we have a circuit that looks something like this, okay, V source, let's say this is R1, R2, R3. In fact, to make it even easier, let's say this isn't a voltage source, but we're given a current source. So this is some current source. Well, if I want to know the current on, let's say, the second resistor. Well, in the past, again, what I'd have to do is I'd have to take the total current by finding a total resistance, use Ohm's law, that gives me the total current, and then I say, okay, how much voltage is dropped by each of these resistors, use the voltage with the resistance, that gives me the amount of the total current on each branch. This is a shortcut, and what it says is if I want the current on the second resistor, then I take 1 over the second resistor, and I divide it by 1 over the sum of each resistor. Take whatever that number is, and I multiply it by the total current of the circuit. Okay, very similar to the voltage divider, but of course, this only works for parallel resistors, and thus you could see this kind of total parallel resistance formula being used with the whole 1 over stuff. And of course, the same goes for if I want the current on the first branch, it would be 1 over R1 divided by 1 over R1 plus 1 over R2 plus 1 over R3, all multiplied by the current. So let's look at a particular example. Let's say I have this circuit here. And let's say I wanted to know what is the voltage across this 4 ohm resistor. Well, if I want the voltage across the 4 guy, I would take the resistance of the 4 guy over the total resistance. So that's 4 over 4 plus 8. And I'd multiply that by the total source voltage. So 4 over 4 plus 8 times 6. And of course this gives me 2 volts. If, for instance, I wanted the voltage on the 8 ohm resistor, well, that would be 8 over 4 plus 8 times the total voltage of 6. And so, of course, that would be 4 volts. Okay, so very fast technique. Unfortunately, it only works if the resistors are all in series. But if you happen to have that, instead of going through the trouble of calculating the total resistance, then finding the total current, and then using the total current on each resistor to get each voltage, you just use this voltage divider technique and get it done fairly quickly. Now, what about for the current divider? Well, let's say we have this particular problem. And I want to know what is the current on the 4 ohm resistor branch. Well, first note that the 4 and the 8 are in parallel. Of course, they share this node and this node in common. In fact, if I were to redraw it, it would look like this. These are the same circuits. So I've got resistors in parallel. I'm looking for a current on one of the branches. That tells me I could use a current divider type technique. And so I say, okay, if I want I on 4, then I take 1 over the 4 ohm resistor and divide it by 1 over 4 plus 1 over 8. And I take all of that and I multiply it by the total current in the circuit. So if I do that, I got 1 over 4 over 1 over 4 plus 1 over 8 is 3 over 8 times 3. So that becomes a 8 over 12 times 3, which is 2. What about the other one? What if I want the current on the 8 ohm resistor? Same exact thing. The only difference is it's 1 over 8 over 1 over 4 plus 1 over 8 times 3. So 1 over 8 over 3 over 8 times 3. 1 over 8 and 8 cancel, so you get 3 over 3. They cancel, and you get 1 amp left. And of course, if we add these two together, 2 plus 1 gives us a total of 3, which is exactly the total current in our circuit. So it all works out okay. So there again, if you run into the situation where you have a circuit, all the resistors are in parallel, and you want to know how much current is on one of the particular branches, this current divider technique allows you to do it a little quicker than if you were to do Ohm's law and all the mess we've been doing in the past. Now the next technique I want to talk about is called the superposition principle. Now, of course, if you're in physics, you've probably seen superposition principle in other forms, especially in things like quantum mechanics and things like that. Superposition principle basically means if you have multiple things all happening in your system, and you want to know the effect, the total effect on your system because of all the things, then all you have to do is add up each individual effect together to get the total effect. That's superposition. Each thing gives a little bitty effect of its own. If you want the total effect, then just add up each individual effect by itself to get the total. Now, how is that going to relate to what we're going to do here? Well, in circuits, you may have a circuit, let's say, that looks something like this. You have a voltage source and a set of resistors, and let's say we also have a current source. So some I, some V, and some R1 and R2. Let's say we have a circuit like this. And I want to know about the circuit. Maybe I want to know the voltage on the second resistor or the current flowing through the first resistor or things like this. Well, one thing I could do is use nodal analysis or loop analysis, as I've done in the past. But this is another technique we could use, and what it says is, I have a circuit. This circuit has multiple sources. I've got a voltage source, and I've got a current source. So I've got two sources in my problem. I can change this circuit into two separate circuits, one with just a voltage source and the other with just the current source, solve each of those two smaller circuits individually, and then add up the answers to each of those to give me the total answer for the whole circuit. That's going to be the point of the superposition principle. Take a complicated circuit, break it down into several smaller, more easy to solve circuits, solve those easy ones, add up all of their answers to get the total answer for the big complicated guy. Now, of course, in order to do this, we need to know how exactly to rewrite these circuits when we get rid of sources. I can't just willy-nilly get rid of a current source and, by throwing away the branch or something. What do I do? And this is how you handle things. If you're getting rid of a current source, so if I'm going to redraw this circuit, keeping the voltage source, but dropping the current source, then when you drop the current source, you turn it into break. It literally means you pretend like you cut the wire where the current source is, you take it out, and you leave a space there. There's a break in your circuit. So, if I were to do this, it would now look like this. The voltage source is still there, R1 is still there, R2 is still there. Here's R1, here's R2, here's my voltage source. And now where I had the current source, I have a little break where it went. That's where the current source was. There's now a break in my circuit there. And this would be the circuit you would work on, solving whatever problem it is you're trying to solve. Just for the sake of an example, pretend you want to find what is the voltage across R2. So you would say, okay, for this particular circuit, what's the voltage across R2? You do your work, you get some V2 due to this. But then we have to redraw the circuit a second time. This time we're going to keep the current source and we're going to drop the voltage source. So let me rewrite the original circuit just so we have it to look at again. Here's my source current, here's R2, here's R1, here's our voltage source. This time what we're going to do is we're going to drop the voltage source and we're going to keep current source. So what's the rule for this? The rule is if you drop voltage source it turns into a short. And what's a short? A short just means wherever the voltage source was, just make it a wire. Okay? So, if I were to do that for this example circuit, so R1 is still there, R2 is still there, the current source is still here. And now, where the voltage source was, it's now just wire. So that's where the voltage source was. I now just short out the circuit, and what that means is make it a wire. So the difference, if we're dropping a current source, it becomes a break. That just means you cut the wire where the current source was. If you're dropping a voltage source, you make it a short, which just means turn the voltage source into a wire. You don't make a break. And again, if this were a real example, I would still be trying to find what is the voltage across R2. So for this particular circuit, I do my work, and I get some V2 for this. And then my answer would be V2 from the first part plus V2 from the second part gives me the total V2 I'm trying to find. And that's what superposition says. Given a full circuit with multiple sources, break that circuit up into individual smaller circuits, each one of those having only one source. For each of those circuits that you've just drawn, solve the problem you're trying to solve. Once you have all of those solutions, you add them all up. That gives you your total final answer for the problem. So, let's do an actual physical problem with numbers. Take the circuit we've been drawing this whole time, and let's put some numbers on it and see how this works. Alright, so we have a 6-volt voltage source. We have an 8-ohm resistor, a 4-ohm resistor, and a 3-amp current source. And I want to know what is the voltage across the 4-ohm resistor. And I'm going to use superposition to do this. So, what does that mean? Well, I have two sources, a voltage source and a current source in this problem. So, I need to draw two smaller circuits. The first one, I'm going to keep my voltage source and get rid of the current source. So, keeping 6-volt source. And so what does it look like? Six, 8, 4, and then I have a break where the current source was, and I want to know what's the voltage here. I'll call it V1 because this is the first circuit we're working on. All right, well, let's look at this circuit. Where this break is, over here, notice, let's say current is running through the circuit. The current's running through, it gets to this point over here, and it could either go this way to the right, or it could go down through this resistor. Well, notice it can't actually get to the right. It can't get over here. And the reason is because there's nowhere for the current to go once it reaches this break. Current can't flow through a break. There's nothing there. And so really, this break is as if that part of the circuit doesn't even exist. And so all you have is the more basic circuit, two resistors, each of them in series with each other, with a voltage source. I want to know what's the voltage on the 4 ohm resistor. So I say, okay, this is a voltage divider. The voltage on 4 is going to be the 4 ohm resistor over the total resistance times the total voltage of the circuit. And that gives me 2 volts. So, for my first basic circuit, the voltage across the 4 ohm resistor is 2. Done. Move on to the second. My second circuit is going to be keep the 3 amp current source and drop all the other sources. So what does this look like? Well, here's my 8, here's my 4, here's my current source. Now where the voltage source was, remember the rule is if you drop a voltage source it becomes a short. So that's just wire there. And again, I want to know what's the voltage on this resistor here. This time I'll call it V2 because it's our second circuit. All right, so now let's look at this circuit. The 8 and the 4 ohm resistors, they're in parallel with each other because they share this node and this node in common. And all of this is just wire on the left side here. So they're in parallel, and they're in parallel with a current source. So I can find the current running through these resistors if I want. In fact, because what I want is the voltage on the 4 ohm resistor, if I know the current on the 4 ohm resistor, I can multiply current times resistance to get voltage. So that's what I'm going to do. Let me use the current divider, because these are parallel resistors, and I'll say the I on 4 is going to be 1 over 4 over 1 over 4 plus 1 over 8, all multiplied by the total current, which is 3. So that's 1 over 4 divided by 2 over 8 plus 1 over 8 is 3 over 8 times 3. And what does that give me? Let's see, this makes this a 2, this is a 1, so this gives me 2 amps. So I know the current running through this resistor is 2 amps. I just calculated that. Why did I do that? Because what I want is the voltage on this guy is going to be his current times his resistance. Well, his current is 2. His resistance is 4. So his voltage must be 8. Alright, now I have the voltage due to the second circuit. I've got the voltage due to the first circuit. I can now solve the problem. The total voltage on this 4 ohm resistor is going to be V1 plus V2, which is 2 plus 8, or 10 volts. And that's how superposition principle is going to work. I start with a complicated circuit that has multiple sources in it. I'm then going to rewrite or redraw new circuits, each circuit having only one source. So if I have 2 sources in my original, I need to draw 2 different circuits. If I have a circuit with 4 sources, then I'm going to have to draw 4 different circuits, each one with one of those sources individually. I then solve each one of these new smaller circuits for whatever it is the question's asking me. Once I have all of those answers built up, I take the total by taking the sum of each of the individual answers. That gives me the total solution, and that's my final answer. Now you're going to see I'm going to post some practice problems on this with solutions. Take the time to look over the practice problems, and we will continue with more techniques next time.